Hello, and welcome. Look up at the night sky. What do you see? Points of light scattered across a velvet black canvas. For millennia, our ancestors looked at these same lights and saw gods, myths, portents. They noticed that while most of these lights held their positions, a few special ones wandered. They called them planetes, the Greek word for wanderers. These wanderers are the planets, our cosmic siblings, each a world unto itself, its own story, its own secrets. Today we're going on a voyage to uncover some of their most astonishing truths. We're going to explore 10 amazing facts about these worlds that will reshape your understanding of our solar system. These aren't just trivia points. They are windows into the fundamental laws of physics that govern the universe. Worlds with crushing atmospheres. Giants that could swallow their neighbors whole. The diversity is simply staggering. Far more inventive, far more strange, far more beautiful. Each fact we uncover is another piece of the grand cosmic puzzle. The story of the planets is, in a very real sense, our story. It's the story of our origins and the context for our existence. So, buckle up your curiosity. Prepare to have your mind expanded. The journey will take us to the edge of our solar system, and beyond. If this kind of cosmic exploration excites you, consider subscribing to the channel. We are fellow travelers on this spaceship Earth. Together, we can explore the cosmos. Let's begin our journey. Let's begin our tour with the undisputed monarch of our solar system, Jupiter. When we say it's big, the word itself feels inadequate. Imagine taking every other planet in our solar system, Mercury, Venus, Earth, Mars, Saturn, Uranus, Neptune, and gathering them together. Now imagine a cosmic vessel, a celestial container so vast it could hold all of them. That container is Jupiter. This gas giant is more than twice as massive as all the other planets in our solar system combined. Our next stop, a world often called Earth's twin, similar size and mass, but this twin took a drastically different path. Meet Venus. You might think Mercury, closest to the sun, would be the hottest. Surprising fact, the hottest planet is actually Venus. Its surface is a scorching 900 degrees Fahrenheit, hot enough to melt lead. So why, tens of millions of miles farther out, is Venus hotter than Mercury? The answer? Its atmosphere. Venus is shrouded in a thick, choking blanket of CO2. Pressure at the surface is over 90 times Earth's. That's like being nearly a kilometer deep in our ocean. The atmosphere acts like an extreme greenhouse. Sunlight penetrates the clouds and warms the ground, but the CO2 traps that outgoing heat. This is the runaway greenhouse effect. Venus is a cautionary tale. Let's linger on Venus for a moment longer. Its strangeness doesn't end with its temperature. We define our days and years by motions. A day is one rotation of our planet on its axis, and a year is one revolution around the sun. A single day on Venus, one full rotation, takes 243 Earth days. Its year is only about 225 Earth days. Let that sink in. A day on Venus is longer than its year. From the hellish plains of Venus, our journey now takes us to the rusty, dusty landscapes of Mars. The red planet has long captured our imagination as a potential abode for life. A world with a history that might mirror our own. While it's smaller and colder than Earth, it holds a record of planetary geology that is truly monumental. On Mars, you will find the largest volcano in the entire solar system. It's called Olympus Mons, and it makes every mountain on Earth, including Mount Everest, look like a mere foothill. This is not just a mountain, it's a geological titan. How big is it? Olympus Mons stands nearly 16 miles or 25 kilometers high. That's almost 3 times the height of Mount Everest above sea level. Its base is so vast it would cover the entire state of Arizona. If you were standing at the edge of its caldera, its summit crater, you wouldn't even be able to see the base of the volcano. The slope is so gradual that the planet's own curvature would hide it from your view. Why can volcanoes on Mars grow so much larger than on Earth? Earth has plate tectonics. Our crust is broken into moving plates. Mars, however, lacks active plate tectonics. Its crust is static, so a single hotspot in the mantle can spew lava onto the same spot for hundreds of millions of years. Olympus Mons is the result of this process, a single, fixed plume of magma building a colossal shield volcano over eons, uninhibited by a wandering crust. It's a silent, frozen monument to a more geologically active Martian past. Let's venture outward now, past the asteroid belt, to the realm of the gas giants once more. Our next destination is Saturn, the jewel of the solar system, famous for its breathtaking system of rings. Those rings are a spectacle, an ethereal halo of ice particles and rock particles dancing in orbit. But the planet they encircle is just as remarkable, and for a reason that might seem unbelievable. If you could find a bathtub, a cosmic bathtub large enough to hold it, Saturn would float. This isn't a metaphor. It's a statement of physical fact based on the principle of density. Density is a measure of how much mass is packed into a given volume. A block of wood floats, while a rock sinks. Saturn is the least dense planet in our solar system. While it's enormous, the second largest planet after Jupiter, its mass is spread out over a huge volume. It is composed primarily of hydrogen and helium. Its overall average density is less than that of water. Continuing our voyage into the cold, dark outer reaches of the solar system, we arrive at a pale blue-green orb, a mysterious ice giant named Uranus. From a distance, it might seem featureless, less dramatic than the stormy Jupiter or the ringed Saturn. But Uranus holds a secret that makes it one of the most peculiar worlds we know. It spins on its side. Its axis of rotation is tilted by a staggering 98 degrees relative to its orbital plane. This extreme axial tilt has profound consequences for the planet's seasons. For a quarter of its long 84-year orbit, one pole is pointed directly at the sun, bathing it in continuous daylight, while the other pole is plunged into a decades-long, frigid night. Our final stop in the planetary tour of our solar system is the most distant planet from the sun, the deep blue ice giant, Neptune. This is a world of extreme cold and darkness. It receives only a tiny fraction of the sunlight that bathes Earth. You might expect it to be placid, frozen, and quiet. You would be wrong. Neptune is home to the fastest, most ferocious winds in the solar system. These aren't mere storms, they are supersonic gales. They rage across the planet at speeds exceeding 1,200 miles per hour or 2,000 kilometers per hour. That's faster than the speed of sound on Earth. Let's now journey back inward, toward the sun, to visit the smallest and innermost planet, Mercury. This tiny, cratered world is a place of the most extreme contrasts imaginable. It has almost no atmosphere to speak of. What little it has is a wispy, transient envelope of atoms blasted off its surface by the solar wind. During its long day, when the sun hangs in the sky, the surface of Mercury can heat up to a blistering 800 degrees Fahrenheit. It's a furnace, hot enough to melt tin and lead. But in the blackness of night, with no atmosphere to hold on to that heat, the temperature plummets to a frigid minus 290 degrees Fahrenheit. This is a temperature swing of over 1,000 degrees Fahrenheit, from scorching heat to cryogenic cold, every single day. And yet, in this world of fire and ice, there is a paradox. At Mercury's poles, within permanently shielded craters, scientists have found evidence of water ice. So on the planet closest to the sun, in the shadows of its searing heat, lie frozen reserves of water. For decades, it was our ninth planet, the final icy outpost in the sun's family. But our understanding of the cosmos evolves, and with it, our definitions. Let's talk about Pluto. In 2006, the International Astronomical Union reclassified Pluto as a dwarf planet, a decision that sparked public debate but was driven by scientific discovery. One of the key factors in this reevaluation was a simple, humbling fact. Pluto is tiny. It is shockingly small. In fact, Pluto is smaller than Earth's own moon. Pluto's diameter is about 1,477 miles. Our moon's diameter is about 2,159 miles. Its largest moon, Charon, is so large relative to Pluto that the two are often considered a binary system, with the center of their gravity lying in the empty space between them. But the final and perhaps most profound fact is that our solar system is not unique. The stars you see in the night sky are not just lonely points of light. Most of them are suns, just like our own. And they have planets too. We call them exoplanets. As of today, astronomers have confirmed the existence of over 5,000 exoplanets, and that number is growing every single week. But that's just the planets we've been able to find so far, the ones in a tiny, tiny patch of our galactic neighborhood. Based on data from missions like the Kepler Space Telescope, we now estimate at least one planet for every star in the sky. Our Milky Way contains hundreds of billions of stars, so there are likely hundreds of billions, if not trillions, of planets in our galaxy alone. For every star you can see, and for the billions you can't, there is a world, or a whole system of worlds in orbit. Hot Jupiters, super-Earths, rogue planets wandering the darkness between stars. The universe is teeming with planets. Our 10 facts have just scratched the surface of our solar system. But out there, in the grand cosmic ocean, there are more worlds than grains of sand on all Earth's beaches. The story of planets is just beginning. And so, our voyage comes to a close. We've journeyed from the crushing, searing hellscape of Venus to the supersonic winds of Neptune. We've seen that our solar system is a place of staggering diversity and scale governed by the same physical laws that operate here on Earth. Each fact is a thread in the grand tapestry of the cosmos. Pulling them reveals our place within it. The universe is not something to be feared. It invites our curiosity. The more we learn about these other worlds, the more we appreciate the delicate, precious, and perhaps rare conditions that make our own world, this pale blue dot, a haven for life. We are, in a very real sense, the universe's way of knowing itself. Thank you for joining me on this exploration of our cosmic neighborhood. What was your favorite fact? Day longer than a year on Venus? The sheer number of worlds beyond our own? Tell us in the comments below. If you felt inspired, please like and subscribe for more journeys into the amazing universe we call home. Until next time, keep looking up.